start the class. Let me show you my screen. Okay, guys. So today, what we are going to start doing is a kind of more serious programming. It's very simple, but it's extremely powerful. Okay, for what we're doing in economics or finance, is something that is called symbolic mathematics. Right? So symbolic mathematics, guys, is simply what we do by hand. You know, for example, if you have a quadratic equation, when you solve the quadratic equation, you have your formula, and then you arrive to a solution that is based on x, okay, values and multiplication of x. So that's symbolic mathematics. Right? And you know, in symbolic mathematics, we can let me move this 1 second. Oh, where's my yeah, let me move this one here. I don't think we need this. Okay, so in symbolic mathematics, guys, we're going to have a distinction between something is called symbols and something is called a character. You see Matlab, right? Guys, you see my Matlab?
Yeah, no idea.
Yeah, perfect. Okay, so as a character, guys, is something like this. For example, I can define, you know, something like this: 2 times x to the power n, for example. So this is a character. You see that? We can also use, for example, let's define a matrix. We can create a matrix, okay? So M is going to be this. We need to start learning this one here, guys. This is string to sim. And then we can write whatever. So for example, A, B, C, D. Okay, so what M string to sim does, guys, is transforms. This is a string, okay? When it's with these ones here, with apostrophes. And what I have created is a symbolic matrix. So it's going to be a 2 by 2. So A, B, C, D. No, and then from here, guys, I can do whatever mathematical operation you want. So for example, we can do M transpose. Let's say this one here is simply M transpose. Okay. We can do inverse of M. Okay. You see that? We can do determinant of M. You see? So we don't need values here. What we need is simply the formulas. And when we develop, and you remember this formula, right? The determinant of M. You remember the formula is going to be AD minus, BC.
Yep.
Okay, so these are very traditional equations. Let's do another way of using symbolic mathematics. Okay, for example, one way of defining symbols is simply sims, x. So this tells Matlab, consider x as a symbol. Okay, and then you can define your functions. For example, f is going to be, I'm just creating whatever, x to our cube divided by sqrt, just something complex, minus x. Okay, so this is my f. So I can do some commands that we're going to use. For example, guys, let's do integral. We can integrate f, and we can do this, for example, in the limits a and b. Okay. So this one here, guys, is integral from a to b of the function f. Make sense to everyone? You know, there were hundreds of rules within integrals. You remember that? I remember having a book of integrals when I was studying that. You have hundreds of books, okay? So at the time we didn't have Matlab. So Matlab can do everything for you. And here you go, right? So that's it. Instead of solving, do you remember these steps, 10 steps to arrive to a solution? Okay, Matlab does in a second. Right? So that's what is beautiful about symbolic mathematics. So we can do also another type of direct definition. So for example, I want to take the difference, okay, and I can define the sim directly in my function of sine of x. Okay, so this sim implies symbolic. Okay, consider symbolic. X is going to be the variable is going to be symbolic, and apply my sine function that we already have. Here you go, cosine of x. Remember, if you take the difference of sine of x, the difference is cosine of x. Remember that? High school math. So we can do, for example, what is the cosine minus sine? Do you understand? So the only thing that we need to tell Matlab is consider this one here as a symbolic. Now, if you have a character, guys, always you need to do, I want to differentiate. If you want to do a character, so if you have a definition of character, it's always a string to sim. Okay? And then I can write something here. Perhaps I can do cosine of x squared minus sine of 2 times x, for example. I'm defining this one. So basically, when you use the apostrophes, guys, this part here is a string or character. So if you want to use this one, and sometimes we're going to use this one. You use the command a string to sim. Okay, and then what we do is we simply take the difference of this symbolic function. Oh, why it's not working here? Cosine. Of course. Let me see if I do this. The issue is that Matlab version 2021 has changed dramatically, so I need to be sure. Oh, no. The way you need to do this is without the definition, sim to a string. Okay, what we do is simply symbolic, and Matlab is going to know immediately what is symbolic here, and then simply develops this one here. This is interesting. So it's not accepting. Let me copy this one here, and let me analyze this case. Sim. Why is not accepting this one here? Oh, so I made a mistake in the previous case, guys, because it should accept. You see this one here? So there are two ways of doing. One is symbolic directly. So for symbolic, you don't need the apostrophes. And the other one is simply, if you want to use the strings or characters, what you do is you simply do the string to sim. Okay. Perhaps I made a mistake on the parentheses, but now it works. Okay. And of course, the result is exactly the same. Makes sense? Another thing that you can do, guys, is before starting something, you can define the symbols. So you can tell Matlab, you know, my symbols are A, B, C, and D. And then you can simply define your M as a matrix A, B, C, D. You see? So you don't need to be writing sims in here like we did before. And then from here, you can compute whatever you can imagine. Okay? So let's do some examples. Can you, for example, do, guys, let me move this in here. Okay, so you do the following examples. So I want you to find if y equals cosine square of x plus sine 3x. Okay, I want you to find dy dx. Right? Can you do that? Then imagine that you have a matrix. A, B, C. I want you to find the determinant of it. I have y y equals x squared plus 3x plus 2. Okay. I want you to find f of y. Yeah, and another property of this command is y equals t to the power 6. I want you to find m. So what I'm saying here, guys, is take the difference 6 times. Derivative 6 times of t to the power 6. Okay? Do a help on diff, and then you're going to identify how to do this. Try here. Remember, you need to define, guys, your symbolics or one by one or in a matrix, okay?
Professor, just letting you know, don't know about my classmates, but at least for me, I don't have a symbolic math 2 box, so I have to install it like right now, so may take a
Yeah.
minute.
Yeah, no, take your time. Ryan, Jack, Jameson, do you have the symbolic? Are you able to do what I've done?
Yeah, I just installed it at the beginning of class, in your beginning.
Oh, yeah, got it. Please install. If you don't have these, guys, you need to install this because it's going to be also part of the final delivery, okay?
Yeah, I also had it installed. Sorry.
Yeah, great. Yeah, take your time. So let's do this just practice this one in 3-4 minutes, and then we come back and solve this together, okay? Okay, guys, 1 minute. Let me change to Matlab. The first one is easy, right, guys? So we can define, we can define f, for example. I can define this as a symbolic, what is this one here? Cosine x squared, cosine x squared plus sine 3 times x. Do you agree, guys? This is my f or y, whatever.
Question: why don't you just define symbolic x and then type out the function and just?
Oh yeah, you can.
Yeah,
definitely,
okay.
you can. And actually, that's one of the ways that I always use is the symbolic first, and then you define whatever you want. But in any case, you can do this. And then basically what you want is diff of f, right? And here we go. Agree? Okay, now for this one here, we can use Kevin's method. So let's do sims. I have a lot: A, B, C, D, A, B, C, D, E, F, G, H. I think I correct. So all of them are symbolics. Then I define my matrix as usual. So it's going to be A, B, C, A, B, C, D, E, F, G, H, A. There you go, guys. So you have defined already your matrix as a symbols, and then you can find the determinant of M. And here you go. Make sense? Questions? So let me do the other one. Where's the other one? Yeah, so I define y equals, well, I will define this as a symbolic here. Symbolic x squared plus 3 times x plus 2. And then I am asking for, again, diff of y. And that's it. Make sense? So it's 2x plus 3. Here's your answer. Make sense to you guys? Then finally, I define a function y again equals, if you want, we can do the sims t. And then I define y equals t to the power 6. And then I do diff y, and I want this 6 times. You see? So that's the way diff works. This is how many times you want to differentiate. 1 time, twice, 3 times, etc. Make sense? Now, sometimes, guys, you are interested. So let me see what is my y. Yeah, let's do another way. One that is with x. This one here. Well, sometimes what you want is to understand which one is the variable that in Matlab is considering. Okay, so for that we use symvar, symbolic variable of y, and it tells you it is x. Okay, for example, if we do let's do symbolic var of 3 times y plus c, for example. Okay, here we have, we have 2 symbolic, we have y, and then we have c. Make sense? Make sense, guys? Yeah, where else do we need to know from here? Yeah, this is also interesting. So let's define sims A, B, and x. Okay, and let's define f simply as a times x to the power 2 divided by b minus x, something like that. Okay, remember guys that a, b, and x are defined as symbols. So what I can do, normally the default is going to be, let's do a diff of f, take a look. So the default for Matlab guys is x, y, and z in that order. X is first, y is second, and z is later. But what if I don't want to differentiate this function with respect to x? I want to differentiate with respect to b, for example. This is the way you do it. Right? If you want the specific variables to be used as the ones that you're going to differentiate with, you simply tell Matlab which one is the one that you want to differentiate. Okay, so let's do some algebraic preparation. So let's do, for example, x. Oh, I need to define my sims. Yeah, well, I can define this here. X squared plus 3x plus 6, and I will define g, another sim. That is going to be 3x squared minus 4 times x plus 5. Okay, 3x doesn't work, it's 3 times x. Okay. Ah, of course, it's not 3x, it's 3 times x. 3x, yeah, should be this. This is correct. Do you agree? This is something that is beautiful, guys, and this just appeared in 2020. It tells you basically what you mean, and actually more than 95% of the time they correct they tell me what I wanted to say. Okay, so what we can do here, for example, is we can do f plus g. I can do f minus g. The traditional math, you can f times g, f divided by g. The traditional operations, guys. Okay, so let's define sims. Okay, another way of defining it, this one here that we used to use in the past is simply, this was another way of saying, another way of stating something that was symbolic. This was the past. Okay, so you define k, that's the symbolic, but now you use this one here. It's more frequent and much more easy. So what we can do, guys, is we can do sim sum. This is our command. K to the power k squared, and I want to sum from 0 to 10. So what is the sim sum? Is that, do you remember let me change my, give me 1 second. So what I want to do is sum of k I squared from I equals 0 to 10. So this is what I'm trying to do. Got it? And the MATLAB for this one here is sim, sum, etc. Okay. Can you do this, please? And can you use, and another one is use linear algebra to compute the same. Instead of doing this one here, I want you to compute the sum of the squares. This is the famous sum of the squares. Okay, 2 minutes to do that. Okay. So let's go to Matlab. Yeah, we have done this already, so this should be it. It's 385. So if you do 0 squared plus 1 squared plus 2 squared plus 10 squared, you arrive to 385. So how we can do this using linear algebra, guys?
With k is a column vector, 0 to 10. You do
Okay,
k.
perfect. So we can define k equals 0, 1, 10, right? Of course, we can create this with simply with 0 to 10, correct? So you're going to have a 1 times 10, 11. And then what do you do to do the squares?
I think you have to transpose that to make it a column vector.
Well,
Right.
if I do this, it's a column vector. Yeah, k
Oh, it
prime,
is?
guys,
Okay.
is going to be a 0, 1, 10. Do you agree?
Yeah.
So a column vector is going to be 11 times 1. So remember that my Simpson is a number. So this is 385. So it's a 1 by 1. It's a scalar. Do you agree? So how do I create a scalar with this one, with these two? So I just need to multiply something. What do I multiply?
K times k transposed.
Exactly. K times K transpose. Do you agree? Because this is going to be 1 times 11, 11 times 1. So this is satisfied. So your result is going to be, okay, let's call it R. It's going to be a 1 times 1. Make sense? Great, Jameson. Good. So we can define that. So let's do this. I will define, I don't know. Yeah, H, okay? So H is going to be 0 increasing 1 by 1. And then I will define H2 is going to be simply H times H prime. Oh, what happened with my H? Not to 1, to 10. Here. Okay. So now, guys, let's go to something that's really cool. Is how do we tell Matlab to execute something? Okay. So one of them, let's define, for example, phi as simply 1 plus squared t, and this is a golden rule, divided by 2. Okay, and I will define this as a character. Okay? If you want MATLAB to execute, so to solve the formula, when you have a character, what you use is simply eval. We have done this before. Remember when we did the names, C, you know, right XLS, open XLS. Remember we use this eval function. So when you have a string, you have defined a string and you want MATLAB to evaluate this string. There is a formula at the end of the day. Simply you say eval of evaluate my variable. Okay, so now perhaps I want to define P as a string, as a sim. So remember, it's going to be a string to sim. Do you understand what I'm doing? No? So if I want to use a string directly, I do a string to sim. If I don't want to use apostrophes, I simply use sim. Thanks. String to sim. Yeah, this is correct. Oh, of course, there is one more. No, this is okay. Yeah, I don't know why is this not working. So string to sim. Yeah. Okay, and then the way we solve it is sim to poly of P. So this is the command for solving polynomial, for solving strings, for solving, sorry, symbols. And so you define, if you want, you define this as a string. So that's why I'm using a string to sim. But you can simply use sim without apostrophes, and the result is going to be exactly the same. Right? And this command here, guys, is something that we're going to be using all the time. Sim to poly simply transforms or evaluates this function. If you have a polynomial, we'll transform this into Matlab language. So, for example, let's do f. Okay, let's define as a string. String to sim. Let's define. I'm just complicating life for nothing. So let me just define this for as a sim. Let's do 2 times x squared plus x cubed. Where's my x? Cube minus 3 times x plus 5, whatever. Okay, remember, symbolic doesn't need the, so 2 times x squared is cube, yeah, for example. Okay, first thing to realize, guys, is that what you do, I put this on purpose, x squared first before x cubed. When you do the sim, MATLAB organizes already this in a decreasing order in the polynomial. All right, now let's do n, and let's say a string or sim to poly of f. Do you remember this one here? Do you remember? We were working with this last class. So this is 5 minus 3x plus 2x squared x cubed, x power 3. Do you agree? Do you remember that? Okay, guys, can you please do create x that goes from 1 to 100, increasing by 1. Evaluate this function on x from 1 to 100 and do a plot. Okay, so what I'm telling to you guys is evaluate this function using x that goes from 1 to 100 and then do the plot. One minute, guys, and then we continue, please. We need to do a lot today. Ready? How the graph looks like? Someone has done this? Guys?
It shows curvature upward. It is
Yes.
concave up.
Yes, do you agree? So if I define x equal 1 to 1, I don't need to write a second 100, but in any case. Oh. And then what I can do is I can simply define, let's say, have h equals polyval. Do you agree? What is my polynomial? My polynomial is n, and I want to evaluate this in x. Agree with me or not, guys? So I have my evaluation. So they can simply plot x comma h. I need to share my. This is a graph. Everyone got this graph?
Professor, just so you know, you're sharing one huge graph right now with no code in the background. But yeah.
Yes. Okay. Makes sense to you? You understand? Now, guys, do you remember the F plot? If you try to do F plot here, you know, you just want to plot F. Remember, that was the beauty about F plot. Here, 100. F plot. You see this one here? So you can use F plot directly, guys. You don't need to do this stuff. But do you remember this command? We did this command before.
Professor, we can't see the graph, by the way.
Man. Yeah. Okay, so let me. Now, do you see the graph? Guys?
Yep.
Okay, perfect. Do you understand? So remember also the fplot command. If you want to have a quick look to the function, you simply do fplot, you define f. You know, where we have defined f. I don't know, somewhere is f. Oh, here. This one here. And then simply fplot is going to graph from 0 to 100. Make sense? Now, guys, if we want to go the reverse, so you know that n is a polynomial Matlab polynomial representation. If I want to go back from the Matlab representation to a symbolic representation, what I will do is let's call it nn, and it's going to be poly as a reverse to sim of n. And then you will the symbolic representation. Okay. Okay, guys, so you need to do the following. Please create an M file that has the following things. So do you remember the eigenvalue, guys? We use, for example, if I give you, I gave you A, and then you compute the eigenvalue. So this was a MATLAB command, and then you compute the eigenvalues of a matrix. Okay, the eigenvalue has beautiful properties in terms of, the sum equals the trace, the product equals the determinant, and the number of eigenvalues that are different from 0 determines the range. Do you remember that? Okay. So what is the eigenvalue? The eigenvalue, guys, is simply a matrix. Imagine that you have. How do you find the eigenvalues? Okay, so what you have is simply you have A minus I lambda, and you equal this to 0. What you do is, this is step number 1. Step number 2 is you find that, so let's call this one, I don't know, M perhaps. Okay, and then number 2, you find the determinant of M. And number 3, you find the roots of M. And these ones here are the eigenvalues. Okay, so what I want from you guys is create an M function. M function. Okay, and inside the M function, you just do this 1, 2, 3, 4, 5, 6, 7, 8, 0. Okay, so create this matrix inside of your eigenvalue. Let's call this my example eigenvalue, and then compute this. So remember, this one here, guys, is a symbol. A is going to be a matrix, so you don't need to do anything. Define lambda as a symbol. So this symbol, let's call it lambda, the lambda of lambda. Okay, then you create a matrix M. If you define symbolics, it's going to be symbolic. Then you find the determinant of this M. Then you need to find the roots of N. But remember, guys, the roots needs a polynomial definition in Matlab. In Matlab terms. How do you find the roots? What is the Matlab command, guys? What is the Matlab command for finding the roots of a polynomial?
Root of the polynomial. So
Yeah, roots. So the command is roots. Okay, guys, so let's do this in 5 minutes maximum. So create your M file and try to do this.
Professor, the function itself wasn't hard. Just so that I need a little bit of an understanding for the mathematic intuition here. Why am I taking the roots again?
Oh, because you know when you do the determinant of a matrix, basically if you multiply this way and minus this way here, you have a polynomial. Do you agree?
Sure.
Okay, and so basically what I want is this equation to be zero. So the only way you can do that is if the roots, so if all the determinant, so you equalize the determinant equal to zero, and then you solve for x. That's what happened.
Oh, okay. Roots is okay. So that's what I'm taking. Zero. Okay, got it. Yep.
Yep, perfect.
Yep.
One more minute, guys. You were able to run this one here, guys? Okay, let me show you this because today we have a lot to do. Take a look. Do you see my screen?
Yes.
Yes, perfect. So a very simple example. This is example eigenvalue. So I'm providing the matrix inside the Matlab inside this M file. What I'm doing is I'm defining lam as symmetric. So remember, you can define this also like this, sims lam. It's okay. This is another way of defining that. So what I will do is I will run up to here. Okay. Then what I do is, what is this one here? This one here, guys, is A minus I lambda. So just let me show you this. Take a look. I will develop this one here. A minus I lambda. Okay, so imagine that A is like that. Like you say 1, 2, 3, 4, 5, 6, 7, 8, 0. This was my A, correct? What is I lambda? I has the same dimension as this one here, so it's going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. That multiplies lambda, a constant. Okay, and then what happens when I multiply a constant? So this is going to be, okay, we'll do 1, 2, 3, 4, 5, 6, 7, 8, 0 minus lambda 0, 0, 0, lambda 0, 0, 0, lambda. You agree? So if I do this, this is going to be simply 1 minus lambda, 2, 3, 4, 5 minus lambda, 6, 7, 8, and minus lambda. Do you agree, guys? This is A minus identity matrix times lambda. So this is this one here. So if we take a look to what we have in Matlab, this is what we have. Got it? Then I told you what we need to do is we simply need to compute the determinant of this. And you see that the power of symbolic, guys, do you agree? Because if you don't have symbolics, you cannot do this stuff. Okay, so now you have a symbolic, you find the determinant, and then you can see it's a cubic function. What we need to do then is need to transform this one into polysim, sim to poly simply transforms this one that is symbolic into a Matlab way of reading the polynomial. So it's going to be constant x, well, lambda squared, lambda cubed. And then you simplify the roots. And then you have the roots. These roots here, guys, are the eigenvalues. Just to show you. So let's do RR equals eigenvalue. Oh, I need to define A. Let me copy A here. I can do eigenvalue A. You see? Yeah, it's simply it's organized, but these are the exact values. Do you have a question? Questions, guys?
I do have one. Just, I know you've said it before, but it wasn't very clear to me. Just exactly what is the application of eigenvalue within econometrics or forecasting?
Oh, for everything. Remember, if you do that, some of these guys. So let me call this, I don't know, RR. Do some 6. Trace of, I call it RR, right? No. Trace of A, 6. So basically, Kevin, to identify, in the non-singular matrix, remember that? A non-singular matrix is a matrix that has a full range. You agree? The rank, not full range. The rank of a matrix should be full. So one easy way to do that, the most efficient way of doing to estimate the rank is simply how many of these values here are different from 0? 1, 2, 3, 3. So the rank of my matrix is going to be 3. It's complete, so it's independent. Take a look. You see that? Now, if you do the product of the eigenvalues and take the determinant of your matrix, you see, these three properties are fantastically useful for mathematics, for optimization, for everything. Okay. Now, what is interesting, guys, if you yeah, Kevin, you were in econometrics last year, right? No, you were not. Well, when we do
I was
co-integration,
last semester. I was with you. Financial economy.
Yes, of course. When we do co-integration, remember when we did the Johansen test, just to find the co-integration relationships, the eigenvalue is used there. And we don't only use the eigenvalues, we use the eigenvectors. Remember the co-integration vectors?
Yep.
They were the eigenvectors.
Okay, so they were just all automated, wasn't evil. That was really it.
Yeah, that's it. Exactly that. The use of eigenvalues, guys, is extremely powerful. And remember, eigenvalues also has a eigenvalue decomposition. Remember, if you want to find the square root of a matrix, if you want to find power 6 of a matrix, you do this with eigenvalue decompositions. We did that in 3 classes before. Eigenvalues are really, really powerful. Okay. Okay, guys, I think that you have, wait. Let me see if I'm forgetting something. Yeah. Before going there, so let's do a couple of other things. There is something that is called easy plot. Okay. And what does easy plot, guys? Simply, so let me define, let's define C. As simply as a symbolic, I will define a cubic, okay? Where's Q? Q to the power 3 minus 12 times Q to the power 2 plus 60 times Q. So this is going to be my symbolic. Oh yeah, this is not a traditional symbolic. So you know what I need to do? I need to do sims. Before doing this stuff, I need to define Q is not a regular, it's not a regular variable, guys. So I need to define this before. So now, yes. So this is a cubic function, okay? We are going to read more about this one here. So let's define AC simply as C divided by Q. So what is this one? My average cost, do you agree? Total cost divided by quantity is my average cost. And then what I can do, guys, is an easy plot. So this is a symbolic, and I want to do AC in the interval 0, 10, for example. I need to change my, take a look to my function. So this is my AC function. Okay, easy plot, guys, works with symbolic. Remember? F plot works with characters or strings. Makes sense to you? Easy plot is one that is gonna work with quadratics. With symbolic. Okay, guys. So now I think perhaps not. Oh yeah, no, we need to know how to solve also. Do you have questions about the easy plot? It's a matter of practice, guys. You're gonna get it. F plot, easy plot. Now let me define a symbolics. Symbolics A, B, C, and X as before. Okay, let's define S as A times X. Where's my square? Square plus B times X plus C. Do you recognize this formula here? It's a quadratic formula, do you agree? A times X squared plus BX plus C. Do you remember this formula, guys? This one?
Yeah.
Okay, so how do you solve that? Remember when we solved, we had a famous quadratic formula. So in Matlab, in order to solve an equation or a system of equations, we simply use the word solve. Do you recognize this formula? Is minus B plus B square root is half. B squared minus 4 times AC divided by 2a, and the other one is this is plus and the other one is minus. This is your famous quadratic formula, guys. Okay, in solve also, you can use the solve function. You can define what variable you want to use. So for example, I want to use the variable b. I don't know what is the reason for that, but you can do that. Oh. And S is there. Oh, I don't need these ones here. Because already b is a symbolic. So you can do that. Okay, but solve is extremely powerful, guys. You can do systems of equations. So for example, let's do another one. Let's do R. Let's do another solve. So let's solve, for example, cosine of 2x plus sine of x, and this one equals 1. Okay, be careful here, guys. So this is a simple equation, but in solve, you use the double equals. This is the way you work in solve, okay? This is a symbolic, just to distinguish between the equal, you need to use equal, the logic equality. And so you have here the solutions. Perhaps we can do some. Another one, guys, for example, if you want to solve equation x squared y squared equals 0, and x minus y over 2 equals alpha. Okay, so this is a system of equations. And I want to solve what are the values of x and y that solve this equation. And alpha is a constant. Okay, so what I want to find is what is the x comma y that solve this system of equations here. So let me take a picture here just to remember what I'm doing. Yeah. So now I can do, I can define my sims x.
Professor, can you go back just a second? I didn't finish writing it.
Oh yeah, definitely. Where is this one here? So you have a system of equations and you want to find what are the values of x and y that solve for this system of equations.
Yep, no, I'm good. Thank you.
Perfect. Okay, so let's program this in Matlab. So I will define sims x and y because that's what I want to find. And let's say R1 equals solve. I copy, let me see, I define this as x to the power 2 times y to the power 2. Right? Yeah, this is, and then I define, the other one was x, the other one was x, what is that?
Minus y over 2
Minus,
equals lambda.
yeah, perfect, minus y over 2. Yeah, let's call off. Yeah, we can call it. Yeah, well, I need to define. I will copy all these guys because I need to define also alpha. Yeah, well, let's call it alpha. I need to define alpha also as a. So I have, yeah, if it's 0, I don't need to do this. You simply say that. X minus y equals alpha. And here we go. Okay, I will explain what is the meaning of this. So I'm just copying, guys. If it's 0, you need to put it. If you want, you put equal 0. It doesn't matter. The default is going to be equal to 0. Okay, this is important, guys, to have a structure. So it means that you have X is a structure that contains 2 times 1, that the size is 2 times 1, and Y also has 2 times 1. So if you want to address one of the elements of X, you do S dot, no, it's not S, is R1, comma, X. So what it will do is basically the solution is going to be alpha, comma, 0. And if you want to see what are the values of Y that satisfy this equation, is R1, comma, Y. These are the other one. Y is going to take the value 0 minus 2 times alpha, right? And this structure, guys, is like any matrix. Okay, so for example, I just want to have the first elements. I will call R1 first. Only the first elements of the matrix. So what I can do is I can say R1, comma, R1 X1. And I want to join this with R1 Y1. And here you go. So it is like a normal matrix algebra. Okay, then if you want everything, of course, you can do R1X, R1Y. Yes, you can call this all. Then you have it. Okay, copy and then you do one. So remember, when you have equal 0, guys, you need to put equal 0. Okay, that's the normal stuff. What you do is the easy thing is to put all equal to 0. So this implies if you have an equal here, equal a value, you move the value to the left, and then you solve the issue. Okay, so you do this. This is one for you. So imagine that you have 2x plus 3y equals 4, and x plus 2y equals 2. Can you please find the values of x and y that solve this equation using solve? Okay. So there is another one, guys, that you can do like that. So you immediately create the output x, y, and then I simply put solve. This was 2 times x plus 3 minus 4. Do you see the trick I'm doing, guys? X plus 2 times y minus 2. So why I'm doing the minus 4 here and minus 2 here?
Does it just automatically assume it's going to equal to 0?
To 0, exactly. So if you want to do equal equals 4, yeah, it should work the same. And then I have it. I have x equals 1/2 and y equals 3/4. Make sense? Make sense to everyone?
Yep.
Okay, perfect. So do you know, I send you these files, I send you files from Alpha Chan photocopies. Can you open please the one that says relationship between marginal cost and average cost functions? Let me open and I will show this to you. And you have it also. This one here. Can you please read 5 minutes and try to do this graph using this function here? So C is going to be this function. You need to read first this document, guys, okay? Understand, it's a very small, just understand from here to here and understand the graph. Okay, and then for the MATLAB example, use this function here. 5 minutes to read, to understand, and then we discuss the model, and then we go into the programming. So guys, the only thing that I want from you is to make this graph, okay? So you can use easy plot, so you need to define the symbolic variables. So if your if your cost is this one here, okay, you need to compute two variables. One, the first difference of this one is your marginal cost. The marginal cost, if you take the first difference, is going to be 3q squared minus 24q plus 60. So this is your marginal cost. And your average cost is simply divide this function divided by q, and then you have your average cost, correct? And then you simply do an easy plot of average cost or marginal cost, and then you have it, okay? Very simple. And you do that, please create an M file. I will give you one M file, but I want you to create first, and then we analyze all the details here. 2 more minutes, guys, and then we'll try to solve it. Okay, guys. So let's take a look to my lab. So now invest, please. 3 minutes maximum. You have this. I have sent these files to you. I have sent you these files to you guys. Can you please take a look? Try to understand everything that is done here. 3-5 minutes, and then we run this one here. Understand, once you have understood the text here in the document, guys, please run this one here. Jack.
Yeah, I read it.
Okay, perfect. So guys, you need to be able to do this stuff. Okay, so the first idea is if I have a function that is going to be a symbolic, I need to do some operation with that. I need to define this as a sim. You can do this. This is all times. You can do simply sims q. That's it. You define your function. Then as soon as this is a symbolic function, you can differentiate. This is what we do all the time. We can divide. So this is my average cost. And then if I do my easy plot, as soon as this MC is a symbolic, I'm doing this between 0 and 10. And then I do the AC. Then I simply do this, let's do this. Show you. This is what you get there. So you remember text, this 720 is simply the position 7 with 20, and the other one is going to be 8 with 60. So just when you put these titles here, labels. Okay, then what I'm doing here is I'm finding the difference. So this is what I was asking to you. Okay, so if you have been able to understand this part here, that's it. Now I'm simply just doing more stuff to show you. So what I'm doing is I'm taking the difference between MC and AC. Okay, so basically what I'm saying is what happens if I take the difference of this one minus this one. So it's going to be positive at the very beginning up to this point, and then it's going to be negative, something like that. Do you agree? So if we run this part up to here. Oh. Here we go. You see? Goes like that, and then it goes like that. So what I'm doing is MC, it's the marginal minus the average cost. So it's going to be negative. So you have 1 0 here, and the other 1 0 here. So if you compare this with this value, so basically I'm having a 0 here, and I'm having a 0 here when they intersect. Agree? So these are intersection values. This one here and somewhere around here. Okay, so what I will do here, guys, is basically testing what I'm doing here. What I am doing here.
What you're doing here, essentially, you're getting a bunch of, you're just getting the symptopolics, you're getting the polynomials, and then you're taking, and then you're taking the polynomials minus each other, which effectively, right, because that's what you would get, and then
this is the mathematical, the Matlab way of the mathematical. Yes. Then I compute D. Yeah.
And to get the roots of it all, and then essentially you're eliminating a root that's 0 because that's not useful to you because it doesn't indicate intersection, or it could, but it doesn't in this case. And then, you just find it, and then evaluate the final value, which theoretically should be the same.
Right. Do you agree? So D, guys, is this function here. No, this is my function. So the graph that I show you there. Then I find that the roots of this one here. So remember, D is going to be a quadratic, right? I have the roots. Then what I do is I find the ones that are not equal to 0. Let me run on this part here. Then what I have here, let me move here. So what is my marginal cost final? It's going to be 6, and my marginal, this is my marginal cost final, and my average cost final is 24. So in terms of the graph, this is somewhere around here. This point here is 24. You see that? When x equals 6, y equals 24. The intersection. You see that, guys? There is 2 points of intersection. One that is not useful for us because it implies that the quantity is 0. And the second one implies that the quantity equals, the average cost equals the marginal cost. So this is my optimal position here. And this happens when we have x6 and y24. And this is exactly what we find here. Make sense to you? So this is a very interesting trick, guys, is when I have the 0 and 6, what I'm telling the Matlab is that just select those that are not equal to 0. So then from the 0 to 6, simply select 6. Once I know that this 6 number is the one that is optimal, I simply transform this one and that's it. Make sense, guys?
Yeah, makes sense.
Perfect. Okay, so let's do one more, an easy one, this is not symbolic mathematics, but I want you to be reading this stuff. Can you please take a look to the Leontiev paper that I sent you? So I sent you one that it was called, no, not this one. Leontiev input output. Do you see this one here? Let me show you my screen.
Out of curiosity, when was the homework due again today? I sent it to you before class, but like.
Yeah, that's okay. Yeah,
okay.
This was before. This was good. Okay, guys, can you please take 5 minutes reading the Leontiev? And what I want from you is basically to replicate, is to find, what are the numbers? They provide an example. Yeah, you have this one here, this is good. So using these numbers here, what I want from you guys is to find, this is the cost of the primary element, basically labor. Then I want to find what are the productions of each of the industries. This is D1, D2, D3. And then what I want from you is basically, what is this one here? It should be around here. Yeah. How much money do we need? It's money in terms of resources, okay? How much money do we need to cover labor, okay, in this economy? So basically, I'm asking you to compute all this part here, from here, the numerical example. Okay, read first the text. Let's say 10 minutes is a kind of long. It's a very interesting model. And then once you have that, you take a look to what you have done in your Excel, in your Matlab assignment, and then see if this works. Guys, work on this because this is going to be more or less what you're going to be doing for a final, okay, for that final project. Okay, 1 minute, guys. Okay, guys. Ready? Guys,
Yep.
okay. Jack, Ryan, I never hear you, Ryan, Jameson.
I'm ready. Yep.
Okay, so now please open the file that I sent you today, input output open economy.m. Okay, now guys, take a look to the example and understand this part here. 3 minutes to do this. once you understand this model, please run and see if it works. But understand the logic, you need to understand the logic. If you have questions, ask me, okay, I'm here. Guys, ready? Do you understand how this works? The best way to understand how this works, guys, is simply do the red dots. Oh, sorry, I cannot do that. Of course, I need to first use D, and I provided D somewhere here. Okay, so this is going to be my D. Then I can run this one here in this way. Okay, so basically I'm saying if the size is not equal to 3, we simply transpose this into a column vector. If I don't have 2 elements, sorry, not 2, 3 elements, I simply say, you know what, there's a mistake. Then we create a matrix A that was given in the example. And remember that primary input is simply 1 minus the sum per column. Agree? Take a look to what happened. What is this one here? Do you see that? So when you say sum A comma 1 implies I will sum by columns. It's 7, 7, and 6. You see? And the primary input simply, guys, is 1 minus 0.7, 0.7, 0.6. So this is my primary input need. So I will need 0.3, 0.3, and 0.4. Now, this is the equation that we have in the paper, not in the paper, in the document. So this equation is, basically this one here. Okay, so that's what we have in here. This is T, is simply I, identity matrix minus A. Then what I do is I simply find the inverse of T to find X. Sorry, inverse of T times D to find X. Then I have my X. My X values is these ones here. My inputs are going to be 24 for first industry, 20 for a second industry, and 18 for a third industry. And then the only missing piece of the equation here now is how much, in order to produce all this part here, these inputs and outputs, how much of the primary input do I need? It's simply my primary input times X. So what is my primary input? Oh, here, this one here. So I need to multiply this times the needs of inputs from the other industries. If you do this, so basically you need 21 billions in order to satisfy all the need of the primary inputs. And this is exactly, guys, what you have in the example that it is presented here. You have this one. Then you have the results 24, 20, and 18. And the primary input should be equal to 21. Do you see that, guys? Guys, this is what I want from you for your final term. Is you need to find any economic, any model that you can simply replicate, and you have an example and do it. If there are simple examples like this, you can do 2 or 3 examples just to be sure. I need to understand what you do, how you do it. And what I want from you guys is to use as much as you can. Okay, if you do the transformation to polynomials, you do optimization, you do whatever to show me that you really know how to do that. If you do, you need to do, I will tell you more, but you need to do plots, subplots, you need to do some linear algebra, some polynomials, just to show me that you are able to handle this one here. Now, the final project, guys, is not going to be necessarily based on something that is written. You can create your own model, okay? And then you just provide me with your model. Now, the last one for today. Can you read? Let me see which one we can do today. And then you are going to have your assignment is going to be to read everything. Once you have read the documents, please do the comparison with the Matlab file that you have, run and understand each step. Okay, that's what you need to do now. I need you to understand that. So next class, sorry, we're going to invest half of the class in talking about the programs. I will give you more examples, and then we talk about individually 5 minutes each. We're going to talk about your personal projects. Got it? So let's do one more. Let's do an easy one. Yeah. Can you open, please? Oh, we don't have this one here. Give me 1 second, I think. Yeah, I can give you one example, and then you solve it. Guys, you have a function, optimization. You have this function, guys. Y is going to be equal to x cubed minus 12x squared plus 36x plus 8. Okay, I want from you guys to do the graph, then find maximums and minimums of this function in the interval -1 and 9. Okay, so remember, guys, that if you have a maximum, so I will just draw any function, and if you have a minimum, okay, so you have always first order condition, that is a first derivative, and the second order condition. Do you agree? So always the first order condition for both of them is that the first derivative equals 0. Do you agree? So this is the first order condition. What is the second order condition, guys? What happens with the second derivative in order to be a maximum? What is the second order condition? Guys,
I
It's
mean,
less than 0. Right?
yes, the second order condition, guys, if this is my maximum, my second order condition, well, I'm drawing like that, should be smaller than 0. Do you agree? The slope of of my peak, when I start going down, my slope is going to be negative. And if I'm in a minimum, my second derivative should be larger than 0. Okay, so that's what I'm trying to tell you. Give me, in this interval, give me the values that are maximums or minimums, okay, and graph, etc. Okay, guys, so basically here, using first order condition and second order condition, okay? Try to do it. I give you this function already. You don't see my screen, right, guys?
We do not see the graph.
Yeah. So let me share. And here we go. Now, do you see my graph?
Yep.
Yes. So the first order condition give me 6. Here was it. So the slope is 0 at 6 and 2. And then the thing is, we need to find basically which one is a maximum, which one is a minimum, right? So that's why I evaluate this one here. I evaluate at these values my polynomial, that is this one here. And then basically, when I evaluate, I get 12 for the first one. And so the first one is with 6. So the first one is with 6. It's positive slope, so means that we're in a minimum, right? And the one that is with 2 has a negative second derivative, what implies that we are in a maximum. Make sense to you, guys?
It makes sense.
Perfect. Okay, guys, so your homework for next class, please, I send you already the material. I will be sending you tomorrow, 3 or 4 more files just for you to read and understand and just get familiar with the things that we want to do. But in general, guys, what I want from you, let me share my screen. So your final project, guys, is going to be independent, okay? However, what I need from you is basically, you need to show me that you know how to program. So you need to have data, okay? Any data. Even though, guys, if you have different pieces of a model, or perhaps just one part that you told me, okay, this is the way I upload data, I read the data, I clean the data, I make graphs, I do subplots. Just show me that you're able to create as much as you can, okay? But the other part that I want from you guys is create a model. Create a model that can be your own model. Can be a model that you can replicate. Okay, whatever. Now, when I say own, it really can be finance, can be economics, or seriously, can be whatever you want. But I need to see something that shows me that you know how to program, okay? I have had models that go from price variation, valuation, portfolio. I have even some of your colleagues in the 5 years ago, he did a horse racing algorithm. So just to basically forecast who was the horse that was going to be winning based on a bunch of historicals. I had one guy that was working with baseball. Baseball has tons of information, and he was forecasting basically who was going to be the next best hitter, something like that. It is up to you. What I need is you to show me that you can program, okay? Data management, graphs, optimizations. So these are the ones that in optimizations. Anything that you can really show me that you are really able to program. Got it, guys. I need to be leaving today early because I have an appointment. But makes sense? So next class, how is next class, guys? We're going to have the first half on solving everything that you should have read. So it's going to be very quick. And after that, we meet just for 5 minutes with each of you. What you need to do is just think, hey, professor, I have this idea, and then, all right, bring a couple of ideas and I can tell you, yeah, this is okay, but you need to add this more, or this idea is too simple, you change this idea. So bring a couple of ideas that you want to implement. Now, it can be from your past work in some classes, whatever. It's up to you. Make sense?
Professor, just a very quick minute.
Yeah. Okay, guys. Questions? All the other ones? Jack, Ryan, Jameson.
Oh yeah.
All good here.
So you're okay? Okay, guys. So we stop here and we see you on Wednesday. Please do what I told you. Okay, go thinking that the final project is really important for you because that's the one together with assignments that I will grade. Okay, guys, talk soon then. See you on Wednesday. So we just stay with Kevin for a couple of minutes.
Sorry, Professor. Real quick, Kevin, if you don't mind.
Yes, Jameson,
I have to travel. I have to travel over the weekend, so I'm gonna start the project like tomorrow as soon as possible.
Yeah.
So I'm gonna email you some ideas tomorrow, and if you can get back to me as soon as possible, I'd appreciate it.
Yeah, I will.
All right, thank you.
Okay, Jameson, take care. Bye bye.
Professor,
wait. Yeah.
Yeah.